Hey everyone, this is a video on numerical system on electromagnetism. Okay, electromagnetic theory, where today we'll be studying Gauge and Lorentz transformations. All right, so let's start. So Gauge and okay, I think yeah, this one will work. Gauge and Lorentz transformation. Okay, so what is it? So according to it, we know magnetic field is the call of vector potential, isn't it? Del cross A. Right? B is equal to del cross A, where A is your what? A is your vector potential, isn't it? A is your vector potential. Now, electric field is what? We know electric field is minus del phi minus del A by del T, okay? Where phi is your what? Phi is your scalar potential. Phi is your scalar potential. And A is your vector potential, as we have written already. So, what is the Gauss transformation? The Gauss transformation is what? So the Gauss transformation is what? So the Gauss or Gauss, whatever you can say, Gauss transformation. Okay, what is Gauss transformation? Gauss transformation will be um, to be A. Sorry. Okay, so A dash is equal to A vector plus del lambda, and phi dash is equal to what? Phi minus del A by del T, right? So these two are the what? Your Gauss transformation. Okay. These two are your Gauss transformation, right? So A dash is equal to A plus del lambda. I will write it again. A dash plus del lambda. Phi is equal to phi minus del A by del lambda. A dash is equal to A plus del lambda. Phi, phi dash. Phi dash is equal to phi minus del A by del lambda. Okay. So E dash can be changed to E through this. E dash can be changed to E. V dash can be changed to P. A dash can be changed to A, and V dash can be changed to V. Yeah, this is your word Lorentz. Sorry, Gauge transformation. There is also Lorentz transformation, right? Lorentz transformation. Lorentz transformation. What does the Lorentz transformation says? Sorry, Coulomb Gauss. So the Gauge, now it's time for Coulomb Gauss. Coulomb gauge. Coulomb gauge. Okay. Coulomb gauge condition is what? Del dot A is equal to 0. This is the condition of Coulomb gauge. Hmm. Coulomb gauge. So del dot E, we know what? We know del dot E is equal to what? Minus rho by epsilon naught. Okay. So del dot, what is E? E is your what? E is your what? If you go up, if you go up, E is your what? E is your minus del phi minus del A by del T. So we put it here. Okay. Put it here. So it will be del dot minus del phi by del A by del T. Sorry. Del by del T is equal to rho by epsilon naught. That implies minus del square phi minus del by del T of del dot A is equal to rho by epsilon naught. Okay. That implies what will happen? Hmm. See, del dot A is equal to 0. Right? Yeah. So I will put that 0. So minus del square phi is equal to rho by epsilon naught. Okay. So del square phi is equal to minus rho by epsilon naught. This is what? This is your Poisson's equation. This is your Poisson's equation, right? So from Coulomb gauge, like after putting this condition, after putting this one, we are getting what? Poisson's equation, right? Next is the Lorentz gauge. Lorentz gauge. See, Lorentz gauge is what? Condition is del dot A plus 1 by c square del phi by del t is equal to 0. Okay. Del dot A plus 1 by c square del phi by del t is equal to 0. Okay. So 1 by c square is what? We know 1 by c square is mu naught epsilon naught, isn't it? Okay. Mu naught epsilon naught. So now what? Now from here we can write this one phi is equal to minus rho by epsilon naught. Uh, sorry. A is equal to minus mu naught z. Okay. So where this del square phi is what? Square phi minus mu naught epsilon naught del square A. So del square phi del p square. Okay. Minus rho by epsilon naught. And where this one is what? Del square A minus mu naught epsilon naught square A by del t square. So we can say what this thing D'Alembert operator or something it's called. So what? Del square minus 1 by c square. 1 by c square del square by del t square. Yeah. Alright. Is it clear? Okay. Yeah. Next. Okay. Let's do a question. Let's do a question. Okay. This is the question. See. This is the question right here. See. Okay. Question right here. It says what? The constant electric current I. Okay. Constant electric current I. Okay. Constant electric current I is what? Yeah, I is infinitely long straight wire is suddenly switched on at t is equal to 0. The vector potential at a perpendicular distance r from the wire is this one. So vector potential is given. Vector potential is given k cap mu naught I divided by 2 pi, okay, ln 1 by r ct plus c square t square minus r square. Okay, alright. So what are you asked? You are asked the electric field at a distance r. Okay, so electric field you are asked. Electric field is how much? So how will you calculate electric field? We know electric field is equal to what? Minus del phi. Electric field from which condition? From gauge and gauge transformation is minus del phi minus del A by del T. Okay, minus del phi by del A by del T. So A is there, right? A is there. Hmm. But what about del phi? Del phi will be 0. Okay, del phi will be 0. Will be 0. So only A is there. So E is equal to. So this one is E is equal to minus del by del T of A. Whatever there is A. Okay. Okay. So uh, that equal to. Okay, I will write it here. That equals to minus del by del T of what is your A? If I add the whole A, okay, if I add the whole A, that will be K mu naught I by 2 pi ln 2 pi ln 1 by R Ct plus root over of C square T square minus R square, isn't it? R square. Okay. So what will I do? I have to take this one as common out. K cap mu naught I by 2 pi I have to take out, and I have to take the derivative of this one ln thing. Okay, so if I take the derivative of this one will become 1 by r ct plus c square t square minus r square. Okay, and a derivative of this one again, isn't it? Derivative of this one again, 1 by r ct plus root over of c square t square minus r square. Okay, so this one is becoming um, just let's take this whole thing as k for now, or c. Okay, c for now, so that it will be easy for us to calculate. No, c is already there, na. Let's take this as k. Okay, this whole k thing. So this derivative will be how much? Now 1 by r will also come out, and the derivative will be c plus again 1 by root over of 2 root over of c square t square minus r square, and here it will be 2ct. So this 2 will be cancelled out now, right? So now what it will become? It will become equal to k. Okay. Okay, let's write down this thing also. Mm, yeah. If I take c out, okay, for example, k by r, c common, 1 plus t divided by, sorry, t divided by root over c square t square minus r square. If you see the question, there is written t is equal to 0. We have to find this is at what? No, t is equal to 0, right? Yeah. Mm, yeah, no problem. That was switched on at t is equal to 0, so there's no problem. Okay, so if I simplify everything and write the final answer, it will be minus c mu naught I. If I put all the values, that will be 2 pi root over. If I put that the value of the k, okay, c square t square minus r square. There was k cap also. Okay, so this should be a answer for e vector. Okay, got it. So what we have to simply do is we have to put the gauge like the Coulomb gauge E is equal to minus del phi minus del A by del T. Okay, this is for E. What is for B? What is for B? B is simply your B is equal to del cross A, isn't it? E is equal to this one, B is equal to this one. Okay, this way we can solve these questions. Now next question. Hmm, next question. Question number 2. Yeah, see. Consider an infinite conducting sheet or in the xy plane with a time-dependent current density k t I cap, where k is a constant. The vector potential at x, y, z is okay. Vector potential is given, isn't it? So vector potential A is equal to mu naught k by 4c ct minus z square I cap. Okay, mu naught k by 4c ct z by but I cap ct minus z whole square I cap. So magnetic field B is asked. Simple question. It looks big, but it's simple, right? My vector potential is given, and you are asked magnetic field. So how will you calculate it? Magnetic field is simply what? Del cross A, isn't it? Magnetic field is simply del cross A. So simply put it del cross A. We just have to take the curl then. V is equal to curl of A. That is the I cap, J cap, K cap, del by del X, del by del Y, del by del Z. Okay. And if you see A is your in I cap, so I have to write it in I cap mu naught K by 4c ct minus Z whole square, isn't it? Yeah, and these ones are 0, 0. So if you see, actually what will happen, okay, let's take it. I cap, this is 0 minus 0, right? For I cap, this will be the one plus j cap, this one minus this one. So let's do it. Del by del z of, okay, first one, yeah, del by del z of that one, that is mu naught k by 4c into 2 ct minus z, and there will be minus also, right? Because minus z is there, minus will be there, plus k cap. For k cap there will be just minus this. Is there any y here? There is no y, so k cap will also 0 minus 0, because del by del y of this one, right? Del by del y of this one is nothing, is because there is no y term here. Okay, so this one is this. And if we solve that, yeah, it's already solved, right? So only j cap term will come, that to minus j cap, and these two, this will be cancelled out, become 2. So mu naught k divided by 2c ct minus z, isn't it? Ct minus z mu naught k by 2c ct minus z, that is minus jk. Alright, this is the answer. Okay, simple again. In the previous question we did what? We took E is equal to minus del phi minus del A by del t. In this question what we did? We took B is equal to B is equal to del cross A. Okay, this works as E electric field is the gradient of scalar potential. Okay, and magnetic field is the what? Curl of vector potential. You just need to remember these two. You can solve a lot of questions. Alright. Yeah, next question. Let's move to the next question. If the electric and magnetic fields are what? Unchanged and the potential A changes to according to A is equal to A plus R. Okay, A is changing to plus R, where R is a what? R of t, I think R cap. Then the scalar potential phi must simultaneously change to. Okay, so phi should change to what? That is the question. Okay, try, take your time. Phi should change to what? See, we know Gauge transformation. Gauge transformation is there, right? We know from Gauge transformation what? What do we know from Gauge transformation? A is equal to A plus del phi, isn't it? A plus del lambda, sorry. Del lambda, alright? A plus del lambda. But in the question, what is given? A dash is actually how much? In the question, A plus R, isn't it? So A to same. So del lambda is equal to R, isn't it? So we can write del lambda is equal to R. Alright? Del lambda is equal to your R, isn't it? Okay. So I can write phi dash is equal to how much? Now phi dash I can write then phi dash is what? What is the formula of phi dash? Phi dash we know phi minus del lambda by del t, isn't it? Phi dash we know what? Del lambda by del t. So can I write it like this? Phi minus del r by del t. Okay, clear? Is it clear? Simple. Okay. We just put in place the lambda r, right? Yeah. Okay. See, del lambda is equal to r. From there we conclude that lambda is what? R. Okay. You will get it. You will get it. See. Uh, okay. Let me prove it then. Then lambda is equal to r vector. For example, I take lambda is equal to r. That means root over of square plus y square plus z square. Take the del of square plus y square plus z square. If you do that, for example, do only for I cap. Take the summation del by del x. Okay, root over of square plus y square plus z square. Okay, so we get what? We'll get what? Summation I cap should be 2 root over of square plus y square plus z square into what? 2x, 2 to cancel, like that for y cap also and j cap also, sorry, k cap also. So x to I cap this plus j cap plus j cap y divided by this plus k cap z divided by, right? So you can see here, I can write it as xi cap plus yj cap plus zk cap whole divided by square plus y square plus z square, which is a what? R vector divided by, that is r cap. Okay, r cap. And if you see the question, okay, this is r vector is equal to r into r cap, right? So this is what you are getting, right? If you see the question, it is written r is equal to r of t r cap, isn't it? In the question, see the question, r is equal to rt r cap. So that's how I proved that lambda is equal to what? R. Lambda is called r. So I just can put here 5 minus del r by del t. Is it clear? Is it clear? Yeah. Like you had some doubt where I did that, like why lambda is r. So I proved it. Okay. The next question. Question number 4. Okay. Question number 4. The component of vector potential is given. Okay. Component of vector potential is given. That is a vector. Component is given on here. So a, that's written as a mu in the question. So a mu. How much is a mu? Okay. A mu is what? Uh, yeah. K. So is that? I'm sorry, I'm reading a bit slow because that pen is just a bit not working today. Z zxt minus xyt. Okay, minus xyz minus sorry zyt zxt and xyt, right? Oh, yeah, the k is in the bracket, so I can write it as minus k xyz kyzt kzxt kxyt, isn't it? So from here, can you tell me this is what, this is which component? This is our ax component, isn't it? This is our ay component. The one that is absent, that is the component. Az component. If these are the this xy component, these are what? This is what? This is our t component, time component. Or I can write it as phi. Okay, this is a phi. So I have everything now then, right? I have everything. So I can construct that a vector. So a vector I can get what? Ax I cap plus ay j cap plus az k cap, isn't it? This is a vector. So ax is how much? Kyz t I cap plus kzx t j cap plus kxyt k cap. Okay, this is your a vector. So this is a vector, and phi is what? Phi is your what? Phi is your minus kxyz, isn't it? Phi is your minus kxyz. Okay. So can I write like we need what? What is the question? Read the question. The three components of electric field are. So electric field is asked. Electric field. Electric field, again we will put that the same formula, isn't it? We have everything. So minus of del minus kxy z minus del by del t of what? These ones, right? So you can write it again. Kxy. So let's do one thing. See, del by del t na. Okay, let me write it. No worries. Kzt t I cap plus plus kzx tj cap plus kxyt k cap. This is del of kxyz minus, see, everything, every term there is t, right? So del by del t of everything, that will be, all the t's will be go, like they'll be gone. So what will be left? Kyz I cap kzx j cap plus kxy k cap, isn't it? Because like t terms are there. So del of xyz, sorry, kxyz minus this one. If you see actually, del of kxyz is what? Kyz I cap plus kzx j cap plus kxy k cap, isn't it? Because del of kxyz. So first del by del x of this one is what exactly? Del by del x of I cap del by del x of kxyz. So that is what? That is your kyz I cap, which is this here. What is it? Okay, this is here. Exactly like this one, like this one. Okay, minus kyz I cap kzx j cap minus kxy k cap. So see, everything is get cancelled. Sorry, everything is getting cancelled out, isn't it? So this answer is what? Zero. Okay, so zero is the answer for this. Okay, again, very simple question. Like what you have to do is we just have to figure out which in the components of A, which are which components, which is your ax, which is your ay, which is your az, and which is your phi. According to that, we will put the value what? E is equal to minus del phi minus del A by del t. I am writing it again and again so that it will be like stored in your mind. Okay, minus del phi minus del A by del t. Okay, next question. Okay, next question is this. Just a second. Let v let v dash a dash denote two sets of scalar vector potential. Okay, v saying what? V va and v dash a dash. This is your scalar potential, and this is what? Vector potential. Okay. Which of the following transformations leave the electromagnetic field unchanged? All right. Okay. Unchanged means what? So electric field will remain electric field like this, and magnetic field will remain magnetic field like this. Okay. So which of the following will do that? So we'll do that. Let's see. Mm, how can you figure it out? We know it. This is a direct question, isn't it? This is a direct question. So we know A dash is equal to how much? A plus del lambda, and phi dash is equal to phi minus del lambda by del t. Simple question. Option here only phi in place of phi there is v. That's it. Nothing else. And in place of lambda there is psi. So I can write it again as A dash is equal to A plus del psi, and V dash is equal to V minus del psi by del t. These are the two equations. Okay. In vector potential it will be added. In scalar potential it will be subtracted. Remember that way. I had remember this way. A plus del psi, and this one is V minus del psi by del t. Alright. So option, which option? Option A only. Option A is the answer. This is a direct question. Next question is question number 6. The scalar vector potentials phi phi xt scalar and vector is axt I determined up to a gauge transformation. Phi dash is equal to phi minus del, what is this, epsilon I think, by del t, and a dash is equal to a plus this one, right? So we further impose the Lorentz gauge condition. Lorentz gauge condition is imposed del dot a plus 1 by c del phi by del t is equal to 0. Then a possible choice for the gauge function ext is possible choice. So what will you do here? Tell me what will we do? Okay. So for this one, this and for the dash one also we'll write del dot a dash plus 1 by c del phi dash del t is equal to 0. All right. So yeah. So what will we do now? We'll just put in place of whatever is given. A is given what? A dash is given what? A plus del lambda del sorry del epsilon. Phi dash is given phi minus. Okay. So put it here. A plus del epsilon plus 1 by c del by del t of phi minus del epsilon by del t is equal to 0. Okay. So this one, if we open it, we del square epsilon plus 1 by c del phi by del t minus 1 by c del square e by del t is equal to 0, right? So I can write it, see if I can arrange it a bit, it will be del dot a, okay, plus 1 by c del phi by del t plus del square e minus, sorry, plus, no, okay, minus 1 by c del square e by del t is equal to 0, isn't it? It's equal to 0. We know this is what it's given, right? It's given 0, isn't it? In the question, it's given 0, and this one is del square e minus 1 by c del square e by del t square. Sorry, there's a square here, na? Is equal to 0. Okay, so del square e is how much then? Del square e is equal to 1 by c square e by del t square, isn't it? Okay, so from here we can write that what? Del square e by del t square is equal to c del square e. Okay, so we have to put those values that are in the options, right? The values that is cos omega t is there, cos omega t, cos h k dot x. You have to put that in this. Which one? In the value of e, because e is asked possible choice for gauge function e. This is a gauge function for which this is possible. So let's put it. Let's put it. So first del e by del t. Del e by del t is how much? Minus omega sine omega t cos h k dot x. Del square e by del t square is equal to how much? Minus omega square cos omega t cos h k dot x. Okay. Now the right side is what? Right side is c del square e. So first you have to calculate del e. Okay. Then you have to take the again that one. After that you will find it. Okay. So if we check all the options, you have to check all the options, and the only option will be cos h omega t. I'll write the answer, and cos h k dot x. That will be your answer. Alright. That will be the answer for it. Okay. How would you know? How would you know this is the answer? See the options. Like we have to like equate the both sides, right? like del square E is equal to what? C del square E is equal to this square, this one. So both sides you can see there is positive. So both sides must be same. So if we take the derivative of everything, see the first option, cos is there, cos omega. So its derivative will definitely be minus. Even if we take the second one, minus will remain there, right? Hmm. Minus will remain there. And second one also, because b cos h no, it won't be there. But if you see the cos h omega t cos h kx, the derivative of cos h is actually sign, positive sign. It's not negative here. So that way you also can solve it. Okay. But it's no problem. You can solve it the better way because you'll get 2 marks for it in gate, 5 marks for it in gate. So better to take your time and solve it. Okay, next question. Next question. Question number 7. Question number 7. Read the question was which of the following transformations VA to V dash A dash V dash A dash of the electric potential V and vector potential A is a gauge transformation. Try to find it. Alright, try to find it. See if V dash is equal to sorry, this won't be vector. Okay. So V dash is equal to what? V plus AX, isn't it? V dash is equal to V plus AX. So we know potential is what? Potential phi minus del lambda by del t, isn't it? For scalar it is minus in the middle. So if we compare this equation, we can write also V dash is equal to V minus del lambda by del t, isn't it? Alright. So del lambda by del t is how much you're getting here? Minus del lambda, sorry. Minus del is AX. So lambda is what? Lambda is what? Minus AXT. Alright. Okay, let's put it now then in place of A dash is equal to A plus del lambda. Okay. So A plus del of minus AXT. Now if okay A my sorry so minus del of AXT. See, del of AX is what? AT will come out as constants because T doesn't have anything to do with gradient, is it? Del X. So del X is what? I cap, isn't it? That means I cap del by del X of X. That is I cap. So this one will become what? A minus AT I cap. Right? So this is answer. A minus AT I cap and B plus AX. B plus X is everything common. So A minus AT I cap. Yeah. This is the answer. Option D. Okay. Option D is your same questions but just different types. Okay. This will give you 2 marks in gate and 5 marks in net. No, not 5 anymore. The 3.5 you will get it for. So, okay, next question. Question number 8. The value of electromagnetic field in a what? Magnetic field in a particular reference frame is A is equal to 3x cap plus 4y cap and B is equal to 3z cap. Alright. An inertial observer moving with respect to this frame measures the magnitude of electric field to be the magnitude of the electric field E dash for the magnitude of magnetic field B dash will be how much? Okay. So you have to remember one thing. E square minus B square is Lorentz invariant. Means it won't change. This value will remain constant. All right. So we can say e square. E square is how much? First of all, tell me. E square is how much? 3 square plus 4 square. That is 25. All right. 25. And b square. B square is how much? 9, isn't it? So that means e square plus b square is equal to sorry, e dash square plus b dash square. So this is your 25 plus 9 is equal to magnitude of e dash is given 4. 4 square is 16 plus this one. So how much it will be? 29, 25 plus 9, 34 is equal to 16 plus dash. This is how much? 18. So b dash square is how much? 18, right? Or what? Did I do a mistake? Oh, sorry. E dash is okay. I got it. I got what I E dash e square plus b square is 25. Yeah. E square plus b square is 25. Sorry. No, no, no. I did it right. Oh, okay, okay. I get it. E square minus b square is invariant. Okay. I did it for a square plus b square. Yeah, this plus is wrong. Okay. This is wrong. What will be the answer? So e square minus b square is invariant. E square minus invariant. Lorentz invariant. So we'll equate them. I did a mistake. My bad. Sorry. Minus b square dash square minus b dash square. E square is 25 and this is 9 is equal to e dash is given 4. Sorry, 4. Yeah, 4. 16 minus dash. So see, this is already 16 is equal to 16 minus dash. So dash will be what? 0. So b dash square will be 0. So b dash will be what? 0, isn't it? This is the answer. Okay, so this is the answer option. Which option is B dash? Is option C. Okay, option C. All right. Yeah, this is all. This is the one. Next question. Question number 9. Vector potential. The vector potential is given is k e to the power minus a t r cap to an electromagnetic field is changed to a dash minus k e to the power minus a t r cap. What? Oh, sorry. Yeah, just the minus is changing there. All right. So again, same thing. So let's put it a dash is equal to a plus del lambda. So a dash is equal to minus k e to the minus a t r cap is equal to k e to the minus a t r cap plus del lambda. So del lambda is equal to, I have to take this side, minus 2k e to the power minus a t r cap. Okay. So this is a del lambda, isn't it? So lambda, how to find it? You can write it as del lambda by del r, isn't it? Minus 2k into minus atr. Okay, atr. So lambda is equal to minus 2k into minus at r dr integration, isn't it? Right. So if I do it, it will be I will be getting minus 2k e to the minus at r square divided by 2. Okay. So minus k e to the power minus at r square. This is a what? Lambda. What we need the question. Read the question. There will be a Gauss transformation. Okay, read the question. The corresponding change phi dash minus phi in the scalar potential is. So phi dash minus phi you are asked. So phi dash minus phi. We know what phi dash is equal to phi minus del lambda by del t. We have lambda here. So phi minus del by del t of minus k e to the power minus at r square. So if I do it, this will be phi plus okay, k. Okay, again minus is coming r square. Phi minus k a minus at r square. So your phi dash minus phi is how much? Which is the question? It is minus ka e to the power minus at r square. Okay, let's check whether which. Yeah, option C is also, if you can check. If you check, option C will be the answer. Okay. See again the same process, isn't it? A dash, phi dash, same things, nothing different. Okay, nothing different is there. All right. Yeah. So these are the questions we did. Like 9 questions in this class, like related to Coulomb and Gauge transformation. Only this type of questions will come from this chapter. Okay, and easy questions, 2 marks easily. You will get it in gate. Okay, so yeah. Okay, that's it for today. Thank you very much.